right, we're going to do 4.2a. Recall, if f of x equals 6x plus 3, then f prime of x equals 6. So let's write something similar to that. We have f of x equals 6x plus c, where c is some constant number. Some constant number. Okay? 3 is a constant. When we take the derivative of 3, it just goes away to 0. So in this case, if we add f prime of x, the derivative of 6x is 6, and the derivative of some constant number is 0. Okay, so we can go from here to here. What if we wanted to go from here back to here? We have something called the antiderivative. Antiderivative. And in this example, it looks something like this, a little squiggly line, 6x, I'm sorry, just 6dx. Okay, this is an integral. We're going to integrate 6dx. And so basically we're going from here to here. So the integral of 6 is 6x, and then we add plus c. This particular one, because there's no boundaries here, we call this the indefinite integral. Indefinite integral. Integral. This pen's too thick, isn't it? Okay, well, we have a little formula that we can use. I'll put it over here. If f prime of x equals x to the a, some number, a, then the integral of x to the a dx equals, we keep the x as it is, we add 1 to the exponent, and then we divide by a plus 1 and add a c. I know that looks new to you, but don't worry, it's not that hard. Let's do an example. So here's an example. F prime of x equals x to the 6. So we're going to start off with that. Now we want to go the other way. So we're going to integrate x to the 6 dx. Okay, so according to this formula, we're going to add 1 to the 6. So we have x 6 plus 1 times 1 over 6 plus 1 plus c. And we'll continue to finish that. So that's 1 over 7 times x to the 7 plus c. All right, let's do some more. Actually, I wanted to show you that we can check this result out right here that we got. I'll rewrite that part again so we can check it out. So what did we end up with? We ended up with 1 over 7 x to the 7 plus c. Okay, so that was the antiderivative. So if we take the derivative of this, we're going to minus 1 from the 7. We get x to the 6. We drop down the 7. So we start all over. We bring the 7 down. Bring the 7 down. Minus 1. Okay? And then we take the derivative of that. That goes away. So what does this equal? 7 over 7, x to the 6, which just equals x to the 6. And that's what we started with. Okay? Let's do another one. All right. We're going to let f of x equal 1/3 x cubed plus 3x plus 4. Okay. f prime of x, we're going to bring this 3 down, and we get x squared because we minus 1. And you bring the 3 down, so we have 1/3 times 3 plus 3, and that's 0. So this just equals 1, and we're left with x squared plus 3. Okay, so let's integrate that now. We're going to integrate x squared plus 3 dx. All right, so according to our formula, we're going to add 1 to the 2. I'm just going to write it out, 2 plus 1. So that's an x. And then we're going to divide that by 2 plus 1. And then we integrate 3, which is just 3x plus c. So this equals 1/3 x cubed plus 3x plus c. Okay. Now that we've done some problems, we can go a little bit quicker with our work. If we integrate x to the 7 dx, well, we know we're going to add 1 to x to the 7, right, to the 7. So we get x to the 8. We know we're going to divide by what we added here. We got 8, so it's 1/8 plus c. So see how quick that goes. You add 1 to 7, get 8, divide by 8. Let's do another one. X to the 10 dx. We're going to add 1 to the 10, divide by that same number, plus c. See, not so bad. Okay. All right. So let's look at some different problems. Let's integrate square root of x dx. We integrate square root of x dx. Let's change that to x to 1/2 dx. That make it a lot easier to add to the exponent when we take it out. So we're going to add 1 to 1/2, and then we're going to divide by what this is, 1/2 plus 1 plus c. Okay. So 1/2 plus 1 is 3/2. This is 1/3/2 plus c. And we know 1/3/2 is just 2/3. X 3/2 plus c. So this is what's cool about having fractional exponents. When we add 1 to them, this number over here is just going to be the reciprocal. Can you see that? All right, so let's do another one where we actually use the reciprocal in what we're doing. So let's say that we start with x to 3/4 dx. That's a 3/4. Okay, we're going to integrate that. So 3/4 plus 1 plus 1 I'm going to change to 4/4, which is 7/4. So now that I know this is 7/4, I know this is going to be the reciprocal 4/7 plus c. So our answer is going to be 4/7 x to the 7/4 plus c. Okay, I'm going to do a couple more, and then I'm going to give you your homework for this particular section. Now 4.2 has more than the homework I'm going to give you, but I'd like you to stop this tape and go do this homework and then come back to 4.2b. Okay, so let's do another example. We're going to integrate x to 2/3 dx. So we take the 2/3 and we add 1 to it. So I'm going to add 3/3. And that equals 5/3. So we multiply this by the reciprocal, 3/5 plus c. And we can rewrite it as 3/5 x to the 5/3 plus c. Okay, one more. Now what if we have 1 over x cubed dx? How would we handle that? Well, we'll just bring it up to the numerator and change it to a -3. That's easier to deal with. Now we're going to add 1 to the -3. So adding 1 to the -3, we get -2. And then we're going to go ahead and divide by that -2 plus c. And so our answer is -1/2. Bring the -2 down to x squared plus c. Okay, so for your homework for 4.2a, when you go into the program, I'd just like you to do 1 through 9 and then come back and watch 4.2b.